Okay, let's open the box and flash the drone with a new firmware. Inside the box you have the drone fully assembled and a remote. Not included is a USB hub, USB OTG cable, HDMI cables required for flashing and setup, battery and battery charger for flights, or a power adapter if you want to do some development on your desk without using the battery. All the references are on the GitHub regarding the batteries and cables and everything. So if you want to develop application for drones, here is a typical lab setup. First, you would have the drone connected to a power supply because it's simpler and safer than a battery. Also connected to a USB hub for the keyboard, mouse, and USB key over a USB OTG adapter and a HDMI screen with a specific micro HDMI to HDMI cable. So that's for the drone. Now, for calibration, usually people would use a tablet or a PC that they could bring with them when they go to fly, and this computer or tablet would run QGone Control. QGone Control can run on Android, iOS, Windows, Mac, Linux, very flexible. And last, you need a development computer that it's not on the photo, where you will type, run your software, and access the drone remotely over the Wi-Fi network. You can code on the computer and transfer your files on the drone for execution, or you can edit remotely over SSH and code on the drone itself. Okay, now we'll have to flash the drone with an updated firmware because you don't want to use the default firmware that comes with the drone. There's a new one that is a lot better already online. So please go to the GitHub for detailed instruction. But to summarize, you'll have to download a large ISO file. You'll create a bootable USB stick from your development station, from a PC. And then you'll flash the operating system. So that's the Linux Yocto running on the compute board. It will also flash the BIOS, and optionally you can flash PX4 or ArduPilot on the flight controller. So the flashing procedure requires a keyboard, screen, and USB key the first time, but the next time you can actually use a command line from the drone remotely to ask for an update without the screen, connected directly to the drone. So all the details are on the GitHub. If you flash the flight controller, you will have to recalibrate the flight controller before you can do anything with it. So this operation is detailed on the GitHub, and it requires QGone Control running on a calibration computer like your tablet or laptop over the network. At the end of the procedure, you should be able to arm the motors without the propellers. That's very important. So it will prove everything is connected. You can also proceed to the first flight if you have some propellers on a battery on a safe place to fly. Here is a screen capture of the flashing procedure. It is not really required. You can go to the GitHub and follow instructions. So first, you would have to press escape when the drone is booting to access the BIOS and ask to boot from USB key. Then it will offer the choice to install or boot. By default, it will install. And you don't need to do anything. It will install automatically without confirmation. So be careful. If you boot from the install key, it will reflash your drone and all your file will be lost. It will reboot automatically and will boot directly from the disk inside Aero. During the first boot, it may take a while because it will reflash the BIOS of the compute board. Next boots will be faster. It will launch a terminal full screen and nothing else. So let's look at the firmware version that we have right now. We have 1.4. And let's look at the IP address that we have. By default, Aero is working as a Wi-Fi access point, and it's called Tether. And you have IP 8.1. On top of that, you have a USB over Ethernet over USB interface called 7.2. So you can plug your PC or Mac directly to the drone and get local access. Now let's try to stop the access points. That's what we do with Tether Wi-Fi off. Launch the WPA agent. Let's scan the Wi-Fi networks, display the different networks. We'll pick this one, so we select with the mouse and we type connect with the name of the connection, then the password, and it's connected. So if you look at the IP address of your drone, you will now have a regular wireless interface, and the IP address will depend on the router DHCP server that you have at home. Now let's try to access internet to see if it works. Let's ping github.com. Okay, I have internet access. I can now install packages and do stuff from internet. To summarize, we flashed all the components, we recalibrated the sensor if needed, and we made our first flight, or at least we armed the motor once to make sure everything works. We are ready to open a terminal on our development station, connect to the drone and start coding.